Pass them forward and keep them in your row. That's what I said. Pass them forward and keep them in your row. Kill them. Sorry. Listen. Oh, also, you can't go to bathroom. Again, you're $2 from your goal. Hi, Friday.
I have $1.
Remember, this is for 6 bonus points. You guys are over the amount already, so Carson, you go ahead and pick somebody.
Oh. Hang on, I might have something. Am I allowed to give this?
Yep.
Am I still allowed to give this, or is it too late?
If you want to, yeah.
There you go.
Alrighty. Okay. So you guys are at $8.05 for today. So that obviously puts you over your goal. So you have 58.05. 2-1. Okay. And who's going next?
You said you wanted to go.
58.05. So far we found initial volume and initial temperature. Oh, let's see. We'll bounce it off again. I don't know what that was. Yeah, I guess that was ready for a loop. Okay, so let's see. All right, we got a second volume. All right. That's a significant figure issue, okay? And it's something that we handle in AP, but we don't handle here. 710 means exactly 710, right? If I say 710 without a decimal, it's like it could be 709.5 to 710.4. It's like it's about 7. So it's about the level of precision or level of certainty.
Where should I put P1?
Wherever you want. Maybe you go next to it, yeah, it's fine. Okay.
Andy Burns.
Nice. Gotta bring Andy into the fold.
No volunteers. Andy Burns.
Okay.
Future 7.
Does anyone want to go? Hi, Race.
He's so
Hey,
nice.
who's got a haircut? He's got a haircut.
Did. Nothing's gonna protect my head anymore, though.
No?
No.
What are we doing?
We want to find the new pressure. So pressure equals. I'm trying to remember here. Is it?
Let's do this. How about you erase that? Okay. And let's start out. Remember, there's a base equation that can handle all the befores and afters.
PV equals nRT.
Well, that's for a single set of conditions. You check it.
Yeah.
What about for before and after conditions?
Do an NRT. What is it? NRT over PV sub 1, all of them equals NRT PV sub 2.
Kinda.
Kinda,
Check,
sorta.
do you want to check your notes?
I'd just love to.
Okay. So there's two equations I told you should be able to do everything with. One is PV equals nRT.
Yeah.
What was the other one?
PV over NRT equals P1 V1 over N1 R1 T1 equals P2 V2 over N2 R T2.
And what happens to R?
It gets canceled out, so.
We don't even have to bother to put that in there. Because if we take that out, that makes another thing easier. If you get the equation, look at somebody else in the manipulate it. Now, n should be lowercase n, by the way.
Sorry.
You're not. Ah, it's supposed to be frozen.
Figures.
There it goes. Okay, who are you calling up now?
But did you go yet? You go yet?
Yeah.
Alright, then, drill.
Alright, so Jarrell, check this out. First thing is something is not changing, okay, we can get rid of it. Is there anything in this thing that's not changing? Well, is P changing?
Yes.
Yes. Is V changing?
No. No, yes.
Yes. Is N changing?
No.
No. So we can get rid of it, so let's just put a slash through N's. And we want to solve for what?
Pressure two.
So let's isolate pressure too. So you're going to do what to both sides?
So I have to bring.
T2 is going to cancel it. No, that's going to make T2 squared. You want it to cancel, so you want whatever you're trying to cancel. Yeah. So that means you have to. Why are we writing in microfiche here? It's in the numerator, so let's just make sure it's clearly in the numerator. T2 up there. Okay, good. And then we're going to divide by what? No, don't do that. Let's make a division bar. See, first of all, I think when you're writing it like this, I think you might be confused that this is actually up here, right? So those cancel. How do you get, yeah, so how do you get the V2s to cancel? The V2 there, and then what do I have to do with V2 now? I do the same thing to both sides.
Alright, so I put B2.
Okay, good. Okay, now you want to select somebody else? How about this person now write what the equation is? Right, so we're going to say P2 equals whatever.
No matter where
Yeah, we'll run out of space, so however you think you can do it and save somebody space to plug the numbers in and then give the answer.
I'll sit at the bottom.
Okay, now before you pick somebody, you can pick somebody in a second here. I got a question about units. Okay. Now, if you're not sure about what to do for units, what should you do? Well,
Change everything to atmosphere. Oh, STD.
no, not STP. Change everything to atmospheres.
Liters, and
Temperature.
Kelvin.
Kelvin, and if we had moles, it would be moles. Everybody clear on that? If you're not sure, that would be the best thing to do, if you don't know when to do it. But that only has to hold true when R is involved. Because R has the units, liter, atmosphere, Kelvin, mole. Is R involved here? No. So when we look up there, if our units of temperature are gonna have to be in what? No matter what, right? And we already resolved that, okay? Our volumes, they're both in milliliters. Is that gonna work? Yeah, because when you plug in milliliter over milliliter, what's gonna happen?
They'll
You cancel
cancel out.
What if one was milliliter and one was liter? You gotta make them the same, and it's probably easier to go to liter just because that's what you have to do sometimes in the other problems, right? And so if the pressure 1 is given in torrs, what's our pressure 2 gonna come out of? It's gotta come out in torr. Okay, so let's get somebody to plug the numbers in. We run all of that. That's right. So you're just gonna say P2 equals and write in all the numbers with all their units. So do you see why putting the units in is important? So you can see if they reconcile. Okay, so
How do we know that N's gonna change?
because it's a gas in a cylinder, and they say that gas is then compressed. They're not saying we're adding gas, they're not saying we're losing gas, it's the
So they
same
don't
amount.
mention.
They're insinuating it, yeah.
There was an airtight cylinder, and you kept pushing down on it. When it came to a point where you couldn't push it down anymore.
Yeah, actually it would. You get to a point where, okay, well, let's put it this way. It would be really hard to achieve, but that's what a neutron star is. Okay? A neutron star is when you've taken matter and compressed it so densely, all right, that you compressed electrons into the protons, making neutrons, and now the neutrons don't repel each other, so it's just neutron, 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 okay? Whereas in real matter, it's like atoms are spaced out like millions of times further. You know, even in a solid, they're millions of times further spaced apart. So like in a neutron star, when you compress matter that dense, okay, it's called super. I forget the name actually, but they say like a teaspoon of it would weigh like 100,000 tons or something.
Oh,
Crazy numbers.
Would that be a super, is that a supersonic?
What's that? No, it's a core of a collapsed star. That's our sun's either going to become a white dwarf, which is fairly dense, or a neutron star. Probably not a neutron star. If the star is a little bit bigger, then when it collapses, it just smashes everything together. If you smash it even further, get a black hole. So this is like the last. This is as dense as matter will get before you go to the black hole stage. So could we do that in a cylinder? Probably not. What would probably happen is if you put enough pressure on it, it's going to liquefy. Because you're going to smash the atoms together. And if you do it even further, you can probably cool it down to solid state.
That's so cool.
Okay, who wants to plug and chug? Tell them, Trey.
Who wants to plug the chug? Ronnie?
Go ahead. Try to hook you up if you need to. So you see milliliters cancel, Kelvin cancel, your answer's going to come out in torr. I could ask you to convert that. I'll tell you too on your test though, be ready to convert, because I do hit conversions pretty good on that test. So know how to go from torr to atmosphere to kilopascals. Kilopascals are the inches of mercury, millimeters of mercury, all those things. So let's see. Let's see if I can do that in my head. 500, that's thousands, that's 500,000. Probably could. So let's see. That's about I'll try. That's about a half. 500 is 250. That's about 10. If it's something like 10,000. No, that's 2. Times 500 is 1,000. It's gonna be like 8,000. Pretty in the middle ground right now.
My grandma's like cylinder and then there's these little balls in it.
It's a temperature gauge.
Oh yeah.
Oh,
grandma's house.
It's based off of density. Density of water changes.
Oh, like by the
Yeah.
she has like 75, 75.
Yeah. So what happens as the water gets warmer, it gets less dense. That means the things will float. the bolder it gets, it'll sink.
So what do they put in the different ones to make sure?
So they put liquids and stuff in there. 5,000? Okay, I was thinking 10, but let's see. I'll trust you on that. Let's see if I get the same thing. He was getting 5,100 torr or so. So that's 710 times 500.